Good morning, everybody. So I'm Raphael Cheverier. I work for Ariane, the launch service provider in Europe. And I will talk to you about how we are preparing for the new wave of the lunar exploration during this decade. So just as a short reminder, I would like to remind that, like I said, Ariane is the European launch service provider. We are a subsidiary of Ariane Group, who is the launcher manufacturer of Ariane, and the rest of the shared capital is shared between several companies that are representing the European space ecosystem, let's say. We are operating 3 launch pads. The main one is in Kourou, and we are also operating 1 launch pad in Baikonur, in Kazakhstan, and one new one in Vostochny in Russia, mainly for the operation of and the deployment of the OneWeb constellation with Soyuz in the framework of a cooperation with Starsem. With the Russian space agency. And so the headquarters are located in Évry, and we have 2 subsidiaries and offices. So 3 actually, 1 in Washington, 1 in Singapore, and 1 in Tokyo, in order to address the satellite market all over the world, which is the prime goal of Ariane in complement to addressing the internal European launch service ecosystem. So just as a short reminder also, we are operating 3 launch vehicles today. The heavy launcher, which is Ariane 5, mainly used to deploy telecom satellites in geostationary orbit. So just to give you an idea, we've launched more than half of the currently in operation telecommunication satellites there. We have used this launcher to deploy emblematic science and exploration missions. The last one was BP Colombo, who is on its way to the Mercury planet. And we have also briefly used it to deploy the Galileo navigation constellation with the European solutions to navigate through satellites. And soon we have 2 very important missions that I wanted to highlight. On December 18th, we will be launching the James Webb Space Telescope, which is going to be a huge historical moment for the company. And the year after that, we will launch the JUICE exploration space probe, which will go to explore the icy moons of the Jupiter planet. We are also using Soyuz for the deployment of the Galileo constellation mainly, and right now to deploy the OneWeb constellations, which we composed of a few hundreds of satellites dedicated to internet connectivity in medium Earth orbit. Actually, we are having a launch right now from Vostochny. It happened 1 hour ago, so I was there to witness it. And the mission, it's a long mission because you have to separate dozens of satellites at a time. So the mission is still going to happen for a couple hours before we can say that it is a success. And we have also been using the Soyuz to deploy emblematic exploration missions such as Gaia, Mars, and Venus Express. And last but not least, we are operating the lightweight launch vehicle Vega, mainly for observation satellites, for example, dedicated to the Copernicus European program, but also some science and technological demonstration missions, such as LISA Pathfinder and the re-entry demo mission EXV. And also some very emblematic satellites dedicated to the climate monitoring from space. So Like I said, we are historically very present on the commercial market in addition to the captive institutional European market. We are present all over the world, and we are already commercializing the next generation of our launch vehicles, Ariane 6 and Legacy, which is a very good transition to my next slide. So next year is going to be a very intense year for Ariane Espace because we are introducing a new generation of launch vehicle, Ariane 6, which is going to be the heritage of Ariane 5, declined in two versions, one with two boosters able to bring 5 tons or more to the geostationary transfer orbit, and the heavy version with 4 boosters, which is going to be able to lift up more than 10 tons into GTO. It has a very nice assets compared to the Ariane 5. It has more performance, more volume under the fairing, and a reignitable upper stage, which makes it possible to address very complex missions. For example, in rideshare configuration, which is going to be very important to perform lunar missions, for example, but I will get back to this later. And also more specifically to address the booming demand for mega constellations, meaning that, for example, with Ariane 6, you can accommodate twice the number of satellites that you can accommodate on a Soyuz flight, for example, to deploy the OneWeb constellation. So it is very important to be present on this market. And we also have Legacy, who is coming next year. It's an updated version of the Vega launch vehicle, able to bring up to 2.2 tons to low Earth orbit, and so mainly to deploy Earth observation satellites, but also to address the very small satellites market that is has a very strong dynamic right now, and especially with the development of multiple launches systems in order to accommodate as many satellites as we can coming from different customers. And just to give you an example, with this carrying structure, we have been able to perform a couple of years ago the first rideshare mission that was carrying a total of 53 different satellites coming from 21 different customers, which was very, very important in order to share the cost between the customers and to really be more efficient in feeding the launch vehicle. And we are standardizing those kind of launch device to the Ariane 6 in order also to do rideshare missions to more energetic orbits. So this is why I'm getting to the topic that is of interest today, how we prepare ourselves to address the emerging lunar market with Ariane 6. So just as a reminder, the lunar market is quite strong. It's mainly driven by the initiative of the US Artemis program to bring humankind back on the moon at the middle of this decade. And we see in this context, and in order to make this possible, many initiatives coming both from the institutions and from the private companies to address a broad range of new lunar applications. Surface mining, lunar telecoms, so with satellites around the moon to make the communications with payloads at the surface, lunar navigations, science, demo missions, and also cargo missions to bring simply materials at the surface of the moon. And we see a strong dynamic inside the European ecosystem, with Europe really willing to be part of this new lunar exploration wave, with Europe participating to the Orion module, which will bring American astronauts on the moon soon. the participation of Europe to some lunar gateway elements, which is going to be the new ISS orbiting the moon to make a sustainable presence of astronauts in the vicinity of the moon. We see also studies in order to implement this European Lunar Logistic Landers EL3, which is going to be able to make regular cargo missions to transport material on the moon. And also this ESA project to implement lunar telecom and navigation system around the moon. And so what we see is that it gets it emulsates a lot of the European lunar ecosystems with private companies having many projects, and especially to develop small lunar landers to do some science and technological demonstration mission on the moon. And we need to address this demand, and this is why we opened a lunar rideshare mission to the moon, meaning that this is a very specific type of missions that we do, because you have lunar surface payloads that are at the direct interface with the lunar landers who will land on the moon, and who are in direct interface with the launch vehicle, meaning with Ariane Espace. So we are preparing to address those kind of missions, and so when preparing, we found that we have several constraints in order to do lunar missions in terms of launcher mission. We see that the moon is varying in inclination, so it has an impact on the way you will address the launch vehicle missions. Typically, it varies from 22 to 28 degrees, so it has an impact on the performance of the launch vehicle. But more importantly, you need to cross the lunar orbital plane, of course, in order to give full flexibility to the lunar passengers. And this means that you will have instant launch from French Guiana in order to choose the RAM. So it gives for some constraints if you want to pair a lunar satellite with something else than a lunar satellite. But the second condition is that even if you launch at instant time, you need to launch it the day when the lunar position of the spacecraft is going to meet the lunar position on this orbital plane. And it means that you will have to choose the argument of parity, and to give full flexibility. In the worst case, it means that you will be able to launch only once day every 2 weeks from French Guiana. So this is why, given these constraints, we decided to open an opportunity to launch a full lunar rideshare, taking into account the high performance of Ariane 6 and the high volume under the fairing, in order to give full flexibility of the lunar passenger, and to so that everybody shares the same launch constraints. So for this, we investigated different injection strategies from super GTO to LTO. I will get back to this on the next slide. And we will be implementing this multi-launch service MLS structure that is going to be proof of concept flighted as soon as 2023 for regular rideshare services, not only towards the moon, but also towards other exotic destinations. And we are also pushing for innovative private-public partnerships, because you know that the lunar missions are mainly driven by public initiatives where private entities take advantage of this in order to develop their ambitious missions. And for this, we have two main credible lunar landers candidates to fill an Ariane 64, but depending on the version of the Ariane 6 that we will use, we are able to accommodate more lunar candidates for such mission opportunity in order to further decrease the launch mission cost per passenger. So like I said, we are investigating different strategies for injecting the lunar passengers. And each has its pros and cons. For example, if you launch in a GTO, super GTO, with a higher apogee than the standard GPO, typically at 80,000 kilometers, with different inclinations options. If you see on the bottom, monoboost, let's say standard injection strategy, means that in order to launch every day from Kourou, we will request from the lunar passengers to keep some propellant in order to make their own phasing strategy with the moon. It means less propellant in order to address its own mission. In order to bypass this constraint, we thought of another intermediate trajectory, meaning that we give an extra boost of the upper stage in order to stay at the, let's say, a parking orbit at 200 kilometers from the Earth, in order to the upper stage to wait there and to reboost at the right time, at the right argument of perigee, in order to meet the moon. It means that the upper stage of the launch vehicle is going to do the job in order to give more flexibility to the lunar passengers. But of course, it has an impact on the global performance of the mission. Another strategy is to actually go into direct lunar transfer orbit, meaning that the apogee of the transfer trajectory is corresponds to the distance of the moon, typically between 380 and 400,000 kilometers from the Earth. And here again, you can either do a mono boost, meaning that you will require some phasing strategy from the spacecraft, or a B boost passing through a circular parking orbit, in order to choose the apogee, the argument of perigee. And so this gives full flexibility of the lunar passengers to perform their final missions around or on the moon. And last injection strategy is using weak stability boundaries with an apogee of 1.6 million kilometers from the Earth, using the L2 Lagrangian point. This is a strategy that will give full flexibility to both the launch vehicle and the spacecraft, but it has the disadvantage of being a very long mission. But typically, the spacecraft will take a couple of months to actually arrive at the vicinity of the moon. So just to sum up here, so we are opening such an opportunity in 2025. We are considering a very flexible architecture under the fairing, either with Ariane 62 or Ariane 66, 64, depending on the number of passengers that we will have. We will use this very versatile architecture, MLS, multi-launch service, in order to accommodate either big spacecraft of about 4 or 5 tons and smaller landers of about 1 ton each, and even lighter CubeSat or very small sats for example, lunar demo missions for telecommunications. We have some prospects that we are discussing with in order to give really full agility and flexibility to the missions to accommodate as many passengers as we can on this rideshare flight with Ariane 6. And of course, we are working very closely with the institutions in Europe in order to make this first flight, European flight to the moon possible with Ariane 6. And I want to, as a conclusion, to say that the booking is open, and we are very open at Ariane Espace to discuss with Lunar Project in order to make this mission possible in the very next future. So thank you very much for your attention, and I'm obviously open with questions.